Stat E 10.2.1, and really again on Monday I'm going to do 10.22, and that's just going to be it'll be an example. We're just going to run through an example together in class, and that's all that is on that note. So it's not new material. So when I said final notes and Monday, but you said there's no more notes. We're going to do an example at least, but notes not material. One proportion hypothesis test. Day one. Day two is just an example. So what we're doing here is we are doing a hypothesis test. More specifically, we are going to be doing what is called a hypothesis test on a proportion. Sorry, wrong one. Where the parameter is a proportion of one variable, P. Okay? So P, remember, as you can recall, is the proportion of ... when we write that sentence, right? Now, because it's a one proportion, in statistics we like to shorten out the wording, we will also call this a one prop, one for one proportion, one prop for one proportion variable, proportion of one variable, z-test. Z, the letter Z is being used because what type of model are we using again? Yes, we're using a Z-table because what type of model are we using? We're using a normal model which has a Z-table. So that's where the Z comes in the name. And the test, because we are doing a hypothesis test. So when you see test, so a one prop Z-test is a one proportion hypothesis test that's using the normal model. So this is important because this is how you're identified in your calculator. All right, when we do this, we talked about step one. Step one for hypothesis test is to do what? Step one is known as the, now we can go yesterday. Whatever. Well, both of them, it's the hypothesis. So this is where we find HO and HA, P equals blank, P is sum, inequality symbol, same thing. We have PO. I'm gonna run through this because it's review, and we can do a less than, a greater than, or a not equal to. And as I mentioned, you can, as Mal mentioned, define the parameter P being the proportion of ... So defining the parameter is an important step because you're going to have to do it at some point. Understanding what your parameter is important. So that's step one. That's what we did. What was that? Tuesday? That's what we did Tuesday. After the exam, right? Step two. Step two is where we do our assumptions checks. Also known as the assumptions and conditions. And the assumptions checks is where we do what again? Check for normality, SIN. This is what we covered yesterday. The sample is random. And the sample is independent or such that N is less than 10% of the population. And finally, normality is where we do N times P0, not P hat, is at least 10, and N times 1 minus P0 is at least 10. Now, in the exam, of course, these conditions will pass, but you got to show it to me that you're doing it correctly. Remember, that's when you're multiplying your null hypothesis times n. You're not using the sample results like you did on your confidence interval. This last check is different slightly than the way we did it on confidence intervals unit 9. So that's all the stuff that we've done already. The last step, step 3, is the new step. We're going to actually do step 3 and 4 today. Step 3 is to find the z-score and p-value. Okay? So as you, and I'm going to put this in red because, again, you don't really have to, I'm not going to make you do it this way. You can choose to do it this way, by all means. If you want to do it this way, the long way, and you're like, and you tell me, mister, I don't know what to do in my calculator. I didn't practice. I totally lied when I showed you that I was being able to write down the right answers. I don't know how to get to the calculator piece. And I'm going to be, okay, do it the long way. That's what I'll say to you. Because you need to know how to use the calculator. And it's not wrong. It will work. Z is equal to p hat minus p0 over the square root of p0, 1 minus p0 over n. And my p-value is equal to a normal CDF piece. So you're going to have to use a normal CDF in order to find the p-value, which we did in the do now. Do you really want to do it that way? I hope you say, oh, hell no. Nope. Don't want to do that. I'm going to make a mistake. I'm not going to know what to do. That seems totally hard. Why are you going to make me do this? Good news. TI calculator to the rescue. Yeah. Your calculator will do this for you. It'll find the z-score and it'll find the p-value for you really, really easily. Okay? Calculator steps. Here's how we do it. You're going to hit stat. Please press that. And you're going to go over to test. All right, please follow along. If you don't press these calculator buttons, if you're not practicing it, if you're not on this computer screen with your TI calc, you're gonna not know how to do it. And when it comes to the assessment, I'm gonna say, nope, I need your phone away if you're gonna be taking one of my calculators, or you can go to TICalc84.com. Those are your options. You can put it up here if you would like to. But I'm not using my calculators anymore. I already gave you that open policy. You can go to the website. You have the app on your phone for those of you that want to give up your phone, Calc84 app. So, or as I'm doing, you go to ti84calc.com, right? That's the other solution that you all have access to so that you see this. This is right. This is open source right here. I didn't do anything. I didn't download anything. I just went to the website. You can even do it on your phone. It doesn't work as good though. All right, I'm going to hit stat, and I'm going to go over to test. Where do you think I'm going to go to? No, close. That's a mistake what people will make. No. More specifically? What is it? No. One prop. One prop z-test. Because that's what we're doing. Now, again, if this was AP, or when you take college statistics, all of these tests and confidence intervals you have to learn. There are all these things. You're like, well, what is that? What is that? What is that? We're not going to use them in this course. The only one we're using in this course, hopefully you're like, yes, is number 5. One prop z-test. Okay? I made you do confidence intervals by hand, but the truth is you can also do one prop z interval, and it'll also be able to get the interval for you as well. That's another thing. That's what I decided not to use when I said, should I use the calculator piece? So one prop z interval, option B finds you the interval, but it doesn't find you what the standard error is or the margin of error is, which is what I asked you to do. But here we need to use one prop z-test. Boom. All right, so then you're going to select option 5, one prop z-test. And when you do one prop z-test, it's going to prompt you. What is P0 for your one proportion hypothesis test? What is X, the number of observed successes in your sample? What is N? And finally, it's going to ask you prop, and it's going to be not equal to P0, less than P0, greater than P0. You must make a selection. This is based on the alternative hypothesis. Branson, follow along. You're going to be completely lost in this, and I'm not going to repeat it. It's all those calculator steps. You input that information, and then you just hit calculate. And it'll give you the z-score and the p-value. And that's all we need. We need the z-score and the p-value. Let's go back to the do now. Let's go back to the do now, where our null hypothesis was p equals 0.24, and our alternative hypothesis for blue M&Ms was p was less than 0.24. We checked our assumptions, and they all checked out. And so now, this was step 1, step 2, and now we're on step 3. Okay? I think that's kind of clear right there. So let's find, we are in the Desmos, we already found the values. Negative 2.22 and 0.0132. But we had to do a lot of calculations. That kind of sucked, to tell you the real. All right, so my P0 is what? .24. My X is what? How many observed successes did I get? How many blue M&Ms were in my sample? 6. What was N? 54. And my prop, I'm going to do, my symbol was less than P0 is what I am selecting. So please, in your calculator right now, I'll give you about 30 seconds. Please type this into your calculator. You should, if you've been following along, like I told you, in your calculator or on your calculator screen, you should be right on the screen right now where this is blinking right here. All right, so I want you to input the information right there. You are there right now if you're following along with me because you want to be doing successful on this next quiz, this final exam, final unit exam. And you're going to have to do this on your final project. You're right here, and you input this information. I put in 0.24. I put in 6. I put in 54, and I did less than. Now, although we're not going to do it, I'm going to show you this one time. What does draw do? Draw actually shows you the normal model with the shading, because that's what we're doing. You see that little itty bitty shading right there? That's the probability of what we're finding. We don't really care for that though. Stat, test, 5, enter. Calculate. And there's my answers. There's my z-score. I got to write that down. I'm going to ask you, well, you need to tell me what is the z-score. Boom. What is the p-value? Boom. I don't actually, this is p hat, which we found early on by hand. We don't need that. Now notice it just says p, but that p stands for p-value. If you do that, you hit calculate. It gives me z equals negative 2.22, and PV, for p-value, is 0.0. Oh, wait a minute. I selected the wrong symbol. That's why my answer is different than yours. Sorry. Second, stat, test, 5. I forgot to change. I actually hit less than, sorry, calculate, 0.0132. There it is. Sorry about that. 0.0132. All right. What is a p-value? Also written as PV. Okay. A p-value is just like we did in practice. The p-value is the probability of getting our sample results if p does equal p0. In other words, the null hypothesis is true. So if 24% of M&Ms are blue, if that's the truth, what's the probability that I only got 6 blue M&Ms or less? 6 or less blue M&Ms. There's a 1.3% chance. 1.3% chance that I got that many blue M&Ms. So that was a pretty lucky bag of M&Ms, or maybe it's either a really unlucky bag of blue M&Ms, right? Wow, there's only a 1.3% chance that I got the amount of blue M&Ms. Or Mars Company, who makes M&Ms, is lying. They're claiming 24%, and it's not 24%, it's lower. All right. Step 4. Told you, big day. Make a decision. When we make a decision, there are only 2 decisions that can happen. 1, we decide to reject the null hypothesis. Or 2, I'll make these the same length. We fail to reject the null hypothesis. Remember, we can never accept the null hypothesis. We either, when the court of law, you reject the null hypothesis, we find the defendant guilty, or you fail to reject the null hypothesis, we find the defendant not guilty. You didn't say we find him innocent. We don't accept the null hypothesis. We just fail to reject it. I'm going to write a couple of symbols that might not make any sense to you right now, but I'll explain. We reject if PV is less than alpha. I'll tell you what that means in a little bit. And we accept if the PV is greater than alpha. I know, what the world does that mean? What is alpha? Well, we know what PV is, but what is alpha? I'm going to tell you that right now. So, for stats, I'm going to tell it right here. Alpha will be equal to 0.05. This is our default, and all we're going to use in this class. So, although alpha can have different levels, you can use a 10% alpha level of significance. You can use a 1% level of significance. In the pharmaceutical world, when they introduced new drugs, when COVID vaccines came out, they used an alpha level of like 0.1%. They had to be so certain that their drug worked that they had to lower their alpha level. If we had more time, I'd go more into what alpha levels mean and all that kind of stuff and why you change them. I don't have the time for that in this course. So alpha is 0.05. We reject, so when PV is less than 0.05, reject the null hypothesis. If PV is greater than 0.05, fail to reject the null hypothesis. Sorry, this is step 4A. It's like a two-parter step. Alpha is also known as our level of significance. I do want to note that. It's also called the level of significance. 4B, answer the question. I know I'm going to go close to the bell. I'm going to get it in time. There is blank evidence to conclude blank. And this is what the null alternative hypothesis, what we're trying to do. And I'm going to put a bracket over here because it might be the word not. There's either evidence or no evidence for us. Either you did find evidence or you did not find evidence. So if you reject, it means that you found significant statistically significant evidence. Yeah. So when you hear in a paper in psychology or any other type of science and they say they found statistically significant evidence, it's because the p-value was less than alpha. Finishing this off with the do now problem. Remember, we got a p-value that was 0.0132, right? That was our p-value. PV is that less than 0.05 or more than 0.05? Is that less than 0.05 or more than 0.05? That's less. So we're going to say that is less than 0.05. So therefore, we are going to reject the null hypothesis. Okay? That's my answer. That's how you're going to look. There is evidence to conclude that M&Ms that are blue is less than 24%. Remember, our goal with the hypothesis, is there less than 24%? Are they cheating us? We found evidence. We found statistically significant evidence that they are. I am now opening up the rest of your pieces. Your homework starts on, or actually, slide 12 on your, I'm gonna try to get this in real quick. If you found statistically significant evidence, that means you will reject the null hypothesis. That means that the p-value is less than alpha. And don't worry about the last question right there. I just wanted to point those two things out. Actually, I'm just going to hide this screen for you guys. Your homework slide's on slide 12. You're doing one problem. There it is. And that's what I have.